Imagine two invisible giants, black holes, locked in a cosmic dance. These aren't stars or planets. They're points in space so dense that not even light can escape them. They don't collide right away. Instead, they orbit each other, spiraling closer over time. Now, here's the strange part. Unlike normal objects, they don't release light, heat, or sound when they move. So how do we know they're there? By the gravitational waves they create. Think of space and time as a stretchy fabric, an invisible sheet that fills the universe. Massive objects like black holes bend and stretch this fabric, just like a bowling ball on a trampoline. When these black holes whirl around each other and get closer, they shake the fabric violently. This shaking sends ripples through space-time, spreading outward across the universe, like throwing a stone into a pond and watching the water ripple in circles. These ripples are what scientists call gravitational waves. As the black holes spiral closer, their dance speeds up, becoming wilder and more intense. Space and time themselves get twisted and stretched in ways that are almost impossible to imagine. To an outside observer, it's as if time itself is racing toward a thunderous climax. Then comes the collision. When the two black holes finally merge, the universe trembles. They form a single bigger black hole, and the collision releases an enormous burst of gravitational waves. The energy carried by these waves in that split second is greater than the combined light of all the stars in the observable universe, yet it's not light at all, but ripples in space and time itself. Even after the collision, the new black hole isn't calm. It rings like a bell, wobbling and vibrating as space-time continues to ripple outward. Scientists call this the ring-down phase, and it continues until the black hole finally settles into a stable, spinning shape, perfectly described by Einstein's equations of general relativity. And here's the astonishing part. We have actually detected these waves. In 2015, scientists at the LIGO observatory heard the faint signal of two black holes merging more than 1 billion light-years away. This event, called GW150914, was the first direct evidence of gravitational waves, confirming a prediction Albert Einstein made a century earlier. Since then, dozens of black hole mergers have been detected, and with each one, we are essentially listening to the universe itself ring. So when two black holes collide, the result is not just a bigger black hole. The universe itself shakes. For a brief, spectacular moment, space-time comes alive, rippling and echoing across billions of light-years, reminding us that even in the darkest corners of the cosmos, the universe is never truly silent. If you like this video, do not forget to like, share, and subscribe for more.